ID lives here in the snapshot. This way, we don't have to manually set it for each one. Instead, it's done for every single resource in this one place. And with that, our fetch item action is ready. Let's try it out by refactoring the fetch post action. This time, we can dispatch fetch item. Give it the resource posts, pass along the ID argument, and the post emoji. So, we'll need dispatch here. We can get rid of the rest of the code and return our dispatched action. If we give it a shot in the browser, something's not working. If we take a look, we misspelled resource. And now, everything is working as before. Awesome. Let's use it in our other actions. They look nice and short now. Notice that we don't need to wrap dispatch in a promise. Since the fetch item action returns a promise, we can return that directly. Now that we have our more generic fetch item, let's look for setPost, setThread, and setUser throughout the store and just change it out to use the generic fetch item. Now we can delete setPost. We'll do the same for setThread. We can delete setThread. And now finally, let's take care of setUser. I'll switch back to the browser to ensure that we didn't break anything. And we didn't. In the next lesson, we will work on composing reusable actions that fetch multiple items. In the created hook of thread show, we loop through the thread's posts in order to fetch them and their users from Firebase. It'd be nice to have an action like fetch posts, plural, that we give it an array of post IDs and receive an array with the post objects when it's done. Because we will need to fetch other resources in bulk as well, we should create a generic fetch items action and reuse it where needed. Fetch items will accept an array with the resource IDs and call fetch item for each one. We'll use .map here instead of .foreach, and you'll see why in just a minute. In order to call fetch item, we have to dispatch it, so we should grab the dispatch method from the context object. Next, fetch items needs to know the resource, the ID, and the emoji of the item we are fetching. So, fetch items also needs to be passed these arguments. Now our action fulfills its first goal, which is to accept an array with the IDs and fetch each one. The next goal is to return an array with the actual items. This is more complex because we don't know when all the items are fetched, since the fetch calls are asynchronous. But each fetch item call returns a promise, so we can wait for all promises to resolve and then group the data each one returned into an array. There's a neat way to do that built into JavaScript using promise.all. Promise.all receives an array and returns a single promise that resolves when all the promises of the array have been resolved. If one of the promises rejects, then promise.all is also rejected with the reason that the first promise rejects with. When it resolves, it collects all the values returned from the promises into an array, so it does exactly what we need. We already have an array with the promises, since we used .map to iterate through the IDs array. Thus, we can return a promise that will resolve when all the items are fetched. And just like that, we are done with fetch items. Now let's create the fetch posts action that we need. Fetch post just needs dispatch from the context object and the IDs of the post to fetch. In here, we will return the dispatch of fetch items. And pass it the needed arguments. We'll need the same kind of action for users in just a second, and eventually for threads, so let's go ahead and create those as well. I'll add them just above fetch posts. Looks good. Let's go put get posts and get users to use over in the thread show page. Here, we want to fetch the post IDs that we have in thread.posts. Then, in order to get the associated users, we'll collect all the user IDs from the post into an array. And finally, we'll call the fetch users mutation. Alright, we can remove the old code. Let's give it a shot in the browser. And everything works fine. But now we have minimized the amount of logic needed in our template and put that burden on the store to expose a more semantic action to fetch multiple resources. If iterating over each ID and fetching each resource in a separate call smells a little bit fishy, don't worry, it does to me too, because I'm used to making async requests via AJAX. Since Cloud Firestore doesn't use AJAX, but rather a technology called gRPC, this isn't as much of an issue. Nonetheless, we'll clean that up a little later on when we introduce pagination. In the next lesson, we will work on getting our home page set up with the persistent data. Now that we have the thread show page working well, and our actions that fetch resources are well prepared, let's go on and fix the home page. The home page has one property, the categories. The categories is the top resource in the tree, and so we don't know the IDs that we need to fetch. That's okay though, because we need to fetch all the categories for the home page, and so we'll implement a unique action for that. I will go into the store and create an action called Fetch All Categories. Much like the rest of the fetch actions, we will log a fire message in the console before we do the actual job. Next, we need to target the categories collection in the Firestore. And listen for the onSnapshot event. The callback of the onSnapshot method receives what's known as a query snapshot. Let's also wrap this in a promise to return from the action so that we can await the result of the snapshot. Alright, we've got this query snapshot, but how does that get us the categories? And what do we do with the categories once we've gotten them? To get the categories, we'll use the .docs property of the query snapshot. We'll also map over each category to give it the ID, like we did to the posts and the users earlier. Then we can resolve the promise with the resulting categories. Cool. That makes the action return the fetched categories. But typically actions call some mutation to mutate the state. And this case is no different. We want our action to add each one of the categories to the categories array in the state. What we want to do here is to commit the set item mutation for each category. We can do that with a short alteration to the callback function we passed to .map. We will also have to access commit through the context argument. Great, this looks good. Let's dispatch our action in the home page. This time, we can dispatch our action inside of the before create hook, since we don't need to have components reactivity ready in order to dispatch our action. The reason for this is that we don't need to pass any arguments to our fetch all categories action, and also we don't need to update the component's data when the call is done. If we take a look in the browser, we can see the categories listed, though we don't see any of the forums. Even though the home page component doesn't use the forums directly, it should be its responsibility to fetch them. It's a good practice for the page components to fetch all the data needed by them or their children, so that the child components can remain simple. So, once we have fetched the categories, we can get each of the forum IDs associated with the categories and dispatch the fetch forums action. First, let's ensure fetch all categories has finished running by making before create an async function, and then awaiting for the categories to finish fetching. To get all the form IDs, we'll call .map on the categories and return the forms property of each category. There is still one problem with this. Each category's form ID exists in their own array, so left as is, their form IDs would look something like this. Notice how the IDs are on different levels of the array. Instead, we want it to have all the IDs on the same level in the array. Thankfully, JavaScript has a super handy method to do just that. It's called .flat. Now, we can dispatch fetch forums. though I don't think we've implemented fetch forums yet, so let's do that quickly. Over in the store, I'll copy fetch threads and change out the necessary items. Let's check it out again in the browser. Great! Now we see all the categories and their forums. Our home page is working again. In the next lesson, we'll fetch all the data needed for the forum page. In the previous lessons, we handled data fetching for the home page, and our store now contains most of the actions we need in order to fetch the data for the rest of the pages. Before we start working on any more of the page components though, I will create the fetch X actions that we missed, such as fetch forum and fetch category. I've created the actions to fetch one item of each resource. I've also created the actions to fetch multiple items for each resource. I have ordered them by resource, where category is the highest and post the lowest, except for fetch user at the very end. To see exactly what changed, feel free to take a look at the source code in the link below. We might not need some of them right now, but it's handy to have them in place. Okay, let's get started with the forum page. Right now, it's missing some things. Let's look at its file. If we look at the computed properties, you see that we need two different resources, the forum and the associated threads. Let's get the forum by dispatching the fetch forum action in the created hook. We'll use the created hook instead of before create because we need access to the this.id that identifies the forum that the page is for. And let's just go ahead and make created async while we're at it, since we'll probably want to do some awaiting in the created hook soon. We also need all the threads associated with this forum. So let's gather up the thread IDs from the forum and pass them to the fetch threads action. Now, looking in the browser, we see that we still have some issues. Let's look in the console. Our first error is cannot read property name of undefined. This is because for just a split second, our forum is undefined. Let's add a vif to the div that wraps our forum. Also, in our threads computed property, let's make sure the forum exists before trying to access its threads. Also, while we're at it, let's alter the thread getter that's used right here in the computed threads prop to return an empty object if the thread isn't found. Let's give it another look in the browser. Alright, we've gotten a little farther. Now we can't read the property name of undefined in the threadlist.view component. Let's go over and fix that real quick. As you can see, we're looking for the .name of the user on the thread, but we haven't fetched that yet. So let's just make our user_by_id function return an empty object if the user is not found. Great, we've mostly got our forum page back. The last thing we need to do is to fetch the users that are associated with each of the threads. That does it for the forum page. Let's keep working on getting all our pages' data coming from the Firestore. The pages that are left are the category page, the create thread page, and the edit thread page. The user profile page still needs some work too, but we'll address that later when we get to using Firebase's authentication service. If we start on the home page and navigate via a router link to a category page, everything works fine. But if we give the category page a refresh, you will see that it's not working properly. The reason for this is that the home page loads all the forums in each category, so when coming from the home page, we already have that data. But if we're visiting the categories page directly, the created hook on the home page never runs, and therefore the data is never loaded. This means we need to load the proper data directly in the categories page as well. We'll add the created hook and make it asynchronous. So, what data do we need? Looking through the category page component, you can see that we're going to need the category specified by the ID in the route parameter. We're also going to need the forums that belong to that category. Inside the created hook, we'll start by getting the forum by dispatching the fetch category action. Specifying the ID provided via the component prop by the route param. To get the forums that belong to the category, we need to access the forums property on the category. Therefore, let's await for the fetch category action and then assign its result to a variable called category. Then we can access category.forums and use those IDs to call the fetch forums action. Now, if we check it out in the browser, the page works on a direct navigation when I reload the page. We do have an error in the console, however. Cannot read property name of undefined. It's not really hurting the page, but it's still nice to try to keep our console free of anything that's red. We can fix this by adding a double pipe to our computed prop and returning an empty object if the category can't be found in the state. This is a result of the data not existing in the state while the async request is still in progress. Cool, the categories page is good to go. Next, let's tackle the thread create page. It has the same problem as the category. It works when we visit it via the router link button. But refreshing the page breaks it. The reason this happens is the same reason it happened on the category page. If we look at the file for the thread create page, you'll see the data we need is the forum that the thread will be created under. Let's fetch it from the Firestore. This time, we don't necessarily need to make the created method async, because there's nothing after fetch forum that needs to wait for it to finish. It'll just get done whenever it gets done, and we're cool with that. We'll also add a conditional to the wrapper div just to be sure the forum is loaded before we try to access its name in the H1. Nice. Now we can visit the page directly. When we click the Publish button, though, we get an error in the console. Cannot read property threads of undefined. This is because the create thread action is trying to append the new thread ID to the auth user, but we haven't fetched the auth user from the Firestore yet. Let's just amend the make append child to parent mutation to warn us in the console for now if the parent resource doesn't exist. And return early. I also see we have a test variable left over here on line 174. Let's just remove that. Now when we try to publish a new thread, we get redirected to a 404 page. This is because the route guard in router/index.js is using the data.json file, imported as source data, to check if the thread exists. Instead of fighting this route guard right now, let's just comment it out and leave time to come up with a more elegant solution later on. One less time over in the browser. Cool, now it creates a thread. We're still missing some of the user info, but that will remedy itself later when we take care of the auth user. One thing to note if we give this page a refresh, the content of our thread is gone. This is because when we're saving the thread here, we're not persisting it to the Firestore yet, only to the Vuex store. Even if we create a new thread again, and then, without refreshing anything, navigate back to the forum that it belongs to, you'll see that it's still missing from this forum. That's because the moment we visit the forum page, it's reloading all of its threads from the store, and our new thread isn't amongst the reloaded ones from the Firestore. We'll work on persisting new threads to the Firestore in just a few lessons. The last page to take care of is the Edit Thread page. Like the other two, it works when navigating via a router link, but we can't refresh it. The only resource it needs is itself. That is, the thread that needs editing. Let's fetch the thread from the Firestore in a created hook. Let's also add a conditional on the wrapper like we did with thread create to make sure the thread is done being fetched before we try to render the template. Let's see where we're at. Cannot read property text of undefined. One more thing to take care of. The text computed property just assumes the post will always exist and automatically tries to access its text property. Let's make it a little more forgiving and then make sure to load in the post in the created hook as well. And we'll add the text computed prop to our conditional on the wrapper to make sure the post is loaded as well before rendering. Whoops, I forgot to remove the .text property here. And let the next line take care of it. Once again, like creating the thread, the update doesn't stick because it's not going to the Firestore yet, but that's okay for now. We're able to hit the update button and redirect correctly without any errors. That gets the data into all our pages except for the user profile page, which will load when we fetch our user. Though we've had a few errors migrating to the Firestore, all in all, it's been a fairly smooth process. The best part is that Vue has provided a nice, clear path in most instances as to what needed to be fixed, with relevant console errors, and with our single file components really being a map to guide us through the data that we needed. In the previous lessons, we used a lot of actions in our components created hooks. To make them shorter, we will map all these actions using the Map Actions helper This lesson doesn't introduce anything new, so you can skip it if you are comfortable with Vuex map helpers. Let's get started with the home page. Here, we use Fetch All Categories and Fetch Forums. So, let's map these using the Map Actions helper. First, we have to import it from Vuex. Now, inside the Methods object, we can use the helper along with the spread operator. I want to map these actions to methods that have the same name as the actions, so I will pass it in an array with the two actions we want to map. And now we can dispatch the actions like normal instance methods. If for some reason we wanted to map the action names to different method names, we could do that with an object. And then we'd be able to call the methods with the new names. But this usually isn't a good idea, as using the same name everywhere is usually easier to keep up with. I'll just Command-Z a few times to go back to using the array to map the view actions. If we try it out in the browser, it won't work. The reason it doesn't work is because in the Before Create hook, the component is not fully set up and the methods are not accessible at this point. If we want to stick with the mapped actions, we have to switch from Before Create to Created. And let's also remove all these console logs from an earlier lesson. Looks good. Next up, let's do the same for the category page. Here, we want to map Fetch Category and Fetch Forums. Next up, the Forum page. And now, the Thread Create page. Here, we also dispatch the Create Thread action, so we can map this as well. Next, is the thread edit page. Remember that mapping Vuex assets, like actions, is not mandatory, and we could, for example, map only fetch threads and dispatch update thread as we did before. The goal of mapping is to make our code shorter. Lastly, let's do the thread show page. We can also make fetching the users a little more elegant here and get the post users and the thread user at the same time by removing the call to the fetch user action for the thread.userid and then concatenating the thread.userid onto the users array before calling fetch users. And with that, we're done. I will walk through our forum to ensure that we didn't break anything. Still works. In the next lesson, we will split our store into multiple files. As our forum grows, the Vuex store is becoming bigger and bigger. It's been tiresome already scrolling through this file to find an action or a mutation. Normally, we'd split the store into Vuex modules, but I want to continue with the Firebase implementation. So, for now, we can split the store into multiple files, one for each asset. To get started, I will create a file for the actions inside the store directory that I will name actions.js. Here, I will export an object that will include all of our actions. Here's a tip for selecting large objects in VS Code. Fold up the object you want to copy first, and then select it. Folding up code blocks like this can also help with navigating a large file. Notice that we have to import a couple dependencies, the Firebase library and the findById helper function. Good. Let's do the same for the mutations. We'll also need to bring over the make append child to parent mutation. It will do just fine living here, since it only applies to the mutations. Lastly, we'll import the required helper functions, upsert and findById. let's move the getters to their own file as well. For the getters, we need to import find by ID. We haven't moved the state yet. The state object is short, and it's unlikely to grow anytime soon. So I like to keep it right here. If you don't, feel free to extract it. Let's import the assets in the index. Now, using the shorthand, we can set them to the state. We should also remove the import statements we no longer need. Nice. Let's make sure it still works. Whoops, can't resolve helper in store. Actions.js. It looks good. Our actions file is still quite large, but it will get better when we implement modules. For now, we can clean it up a bit by declaring all the actions that fetch a single resource and multiple resources that return an action call using arrow functions. To do that, we can use the colon and then add the arrow after the arguments, and then get rid of the braces and the return. Let's also do the same for the rest of the fetch functions. In VS Code, I'll select what's similar between them all and press Command+D a few times to put multiple cursors in place on each function. I can also use the Command plus the arrow keys to jump to the beginning and the end of the line, and the Command plus Option keys to move one word or a block of characters without a space at a time. There, that looks a little better. Let's go back to the browser. Great, everything is still here. In the next lesson, we will bring back the auth user getter before we start writing data to the Firestore. Before creating the actions to fetch data, we hard-coded the auth user getter to return null. Although this is fine until we implement authentication, it will be easier for us to work with creating posts and threads in the Firestore by having a local user object. All we have to do is to call the fetch user action and fetch the user with the auth ID from the database. The question is when to fetch it. The auth user is used in all the pages because it's used in the navbar. So, one option is to make the call in the navbar's created hook. Since it's used in all the pages and there will always only be one instance, though it isn't navbar's responsibility to fetch the authenticated user or do other similar tasks. Whenever we need to run code on every page, we can use the app.view file. As in all the page components, we can use the lifecycle hooks to run code at certain times for the app.view component. Only since it's the root component, it will apply to every single page. Let's use Vuex's map actions to make the fetch user a method of the app component. Now, all we have to do is call the fetch user action in the created hook, passing it the auth ID stored in the state. This should do it. Nice. Bruce Wayne is back. I'd been missing that little guy. There's one more thing that I want to do here. It feels kind of weird to reach into the store state to grab the auth ID and then pass it into an action that's also defined in the store. Since the store already knows about both of these pieces of information, and I think it could be useful in the future, let's create a fetch auth user action. We can copy the fetch user action and rename it fetch auth user. It will no longer have to take in an ID, but instead we can reach into the state and get the auth ID. Then we can call the fetch auth user instead of fetch user over in app.view. And we'll no longer have to pass the auth ID. Awesome. In the next lesson, we will store the posts that users create in the Firestore. In this lesson, we're going to get newly added posts actually persisting to the Cloud Firestore. To do that, we'll update the Create Post action here in our store. First, we'll need to make the action async, since calls to Firebase will be asynchronous and we'll want to wait for it to finish. We want to store the post in the Firestore right before we commit the mutations to store the post in the Vuex store. So, how do we add a record or a document to the Firestore? Conveniently, Firestore provides an add method. To use it, we target the collection that we want to add the document to. And then call add, passing it the post to add. We'll also await for the request to finish so that we can assign the result to a new variable called new post. This will allow us to access the auto-generated ID of the new post. If you take a look at the mutations below, you see that not only do we have to save the post, but we should also append the post ID to the thread and append the user ID to the contributors property of the thread. We should do the same thing in the Firestore. Besides the add method, the Firestore also provides an update method we can use to update the thread to include the post ID and the user ID. So, we'll target the thread collection Then the thread that matches the thread ID on the post, and then call update, passing it the properties we want to update. But we don't want to completely override the post and contributors properties. They should be an array that keeps track of related posts and users. So, what we want to do instead is add the IDs to the posts and contributors array. Firestore provides an elegant solution for this. We can call firebase.firestore.filledValue.ArrayUnion on the values that we want appended to the array. Not only will ArrayUnion append the IDs to the contributors property, but it will also only append it if it doesn't already exist in the array. So we don't have to worry about making sure the contributors property doesn't have any duplicates. Let's await the update to finish as well, just to make sure that it's complete before committing the mutations to the state. Lastly, let's get rid of our hacky ID generation and give the ID generated by the Firestore to the setItem mutation. Let's also give the new post ID to the append post to thread mutation. Now, we should have a persistent post. If we add a post now and submit it, we see that it shows up on the list, but what happens if we refresh the page? Awesome, it still exists. This is just what we wanted. Let's do a couple more things to tighten things up. Take a look at the Firestore portion of our code. If we save the post successfully, but then for some reason the Firebase service becomes unavailable, we don't successfully update the thread to append to the post and the contributors. This is a problem, because now we have a new post just floating around in the database without its relation to the thread properly saved. Not only will the post not show up on the page, but we've contaminated our database with bad data. How can we resolve this? The solution is using a Firestore batch to send the add post and update thread calls in a single transaction. First, we have to create a batch. Then, we need to call the add and update methods on the batch instead of the collections. As you look at this, though, you might be wondering, how does the batch know which collection to post to? All we've given it here is the new item to add, but we don't know what to add it to. The first argument given to batch add and update methods should be what's called a document reference. We can create a document reference to the new post by calling firebase.firestore.collectionPosts.doc. When the document reference is for a new document that doesn't already have an ID from the Firestore, we can call doc without any arguments at all. We'll call the document reference, PostRef, short for post reference. We can do the same for the thread, this time passing the thread ID to the doc method. Now we pass the PostRef to batch.add. And actually, there is no such thing as a batch.add method. Instead, it's called batch.set. This is because now the reference actually already exists, that is, the PostRef, though it only exists locally in memory and not in the FARStore. But even still, FARStore changes the method name here to make more sense with an existing ref. We'll do the same thing for batch.update with the thread ref, and change out new post.id for postref.id. Notice we don't have to use await on either batch.set or batch.update. That's because neither one of those is actually making an async request to Firebase. Instead, they are just recording locally in the browser what should exist in the batch that we can now send to Firebase in a single request with batch.commit. We do have to await batch.commit now to be sure it completes before updating the state. And then we can remove the old individual calls to FARStore. Give the page a refresh and add a new post. And refresh. And yeah, awesome. We're still persisting data as expected. In the next lesson, we'll update the way we're setting the timestamp so that it's a timestamp set by the FARStore server and not by our local machine. Right now, we're using date.now to set the timestamp for the published app property for new posts. When working with the Cloud FARStore, it's best practice to use the server timestamp instead. There are a few reasons for this. Number one, the timestamp on a client is frequently off from the actual time on the server, meaning that the two values will be different. Number two, if you write the timestamp from the client, that means that a malicious user can provide their own value, whatever they like. Number three, a client is guaranteed to have some latency in its connection to the database, which means that even on a perfectly set client and with a perfectly friendly user, there's still going to be a difference between the values. And number four, if you use a server timestamp, you can enforce its values in security rules. So let's change out date.now for the server timestamp. Let's check it out in the browser. Now, when we add a new post, you'll see that its publish date is not a number. There's a couple reasons for this. If we inspect with View, you'll see that the published app property is set to an object with the key of delegate. That's because we're setting the post we defined locally, and it has no idea what the timestamp of the server actually was. When we set its published app property to the server timestamp, we actually just set it to a placeholder that instructs FARStore to use the timestamp on the server when we actually set the data. So, instead of passing the locally created post object to the setItem mutation, let's get the post directly from the FARStore. We get the post from the FARStore on page load anyway, so Doing this will mitigate any differences between how we set things to the Firestore and how the data looks coming out of the Firestore. Now, when we add another post in the browser, the not a number issue is gone, but now every new post is added 1969 years in the future. Hmm, that's not right. If we look in the View DevTools, we see that the Firestore server timestamp looks a little different than the date.now timestamp. It's an object with two properties, one with the timestamp in nanoseconds and one with the timestamp in regular seconds. While our normal date.now timestamps are just the timestamp in seconds. Since we've got timestamps saved both ways, some from the import and some from the Firestore server timestamp going forward with all new posts, let's alter the app date component to be able to handle both. It's worth noting, in a real application, you'd probably want to normalize the data in the database and make all the timestamps look the same. But this solution will work for our imported test data. In the app date component, we'll update the timestamp prop to be either a number or an object. Then, we'll create a computed prop that normalizes the timestamp to be just the timestamp in seconds. We can use the question mark to tell if this .timestamp is indeed an object with the property of seconds, like provided by the server timestamp. If it's not, it's just the regular timestamp, like from the imported data. Then, we'll use the normalized timestamp for each of the methods below. And since these methods don't have any arguments provided, while we're at it, we can change them into computed props. And remove the parentheses from where they're called above. Awesome. Now the published at works with adding new posts, and if we refresh the page, everything is still looking good. Now that we have posts persisted to the Firestore, we can do the same for threads. We'll start it off with the batch this time. Looking at the commits below, we'll need document refs to the new thread, a user, and a forum. The thread ref won't have a parameter provided to the doc, as it will be a new thread. The user ref will reference the document of the authenticated user. We've stored in a user ID variable above. And the forum ref will reference the document that matches the forum ID given to the action. Now we can define all the transactions that should be bundled up into the batch. First, we need to set the new thread. Then, we append the thread ID to the user. Then, append the thread ID to the forum. Lastly, we'll commit the batch. We also need to use the ID generated by the Firestore everywhere. Just like with the post, let's also use the server timestamp. Again, like with the posts, we should fetch the thread document from the Firestore to pass on to the Vuex set item mutation. Since the create post action is actually doing asynchronous stuff now, let's await for it to finish before returning the thread. Let's see how it works. And we have a quick error in the console. These should be properties and not methods. Try it one more time. Nice. Our thread shows up. The thread count on our homepage has increased. And there it is, listed in the forum. You may have noticed that since we've started getting the posts and threads from the Firestore, the posts and threads counts have been off. For instance, if we give the page a fresh reload, visit the Pets forum, and in the first thread here, you'll see that Bruce Wayne has one post. Then, if we visit Jokes and Batman Jokes, now all of a sudden Bruce Wayne has two posts. Let's take a look at why that is. In getters.js, in order to get the posts count, we're getting the length of this .posts. This .posts is a reference to the native JS getter just above. The posts getter returns all the posts in the Vuex store's state, that are related to the user. So, this explains it. The posts count only knows about the posts in the local Vuex state, but the Vuex state is only filled with particular posts depending on the page we visit. This worked fine for the JSON data, but it's not practical to load in all the posts from the Firestore at one time just to get the count of a particular user's post. In fact, it'd be downright bad practice. So, how should we get that post count? We could do like the threads, where the user has a threads property equal to an array of all the threads that the user has created. However, the number of posts a user creates has the likelihood of being a lot more than the threads that they create, and I'm not sure I want to store that many IDs in an array on the user that will have to be fetched every time the user is fetched. Besides, this will be a good opportunity to show an alternative approach. The alternative approach will be to add a posts count property to the user in the Firestore itself, instead of computing it on the client side and incrementing that posts count property every time we create a new post. Alright, let's do it. Over in actions.js, let's update the createPost method to do that incrementing. We'll need to get a document reference for the user, just like we did for PostRef and ThreadRef. Then, we need to add the user update to the batch. But what do we set posts count to? Thankfully, Firestore is used to this approach and provides a useful function. It takes a parameter specifying the amount to increment the number. We just want to increment it 1 for each post created. It's also nice that under the hood, if the post count property doesn't already exist on the user, the Firestore will just act like it's 0, and this incrementing will work as expected. This means we don't have to check if post count exists first in order to increment it. Back in getters.js, let's update the posts count property to use the new posts count saved in the Firestore. And then, just in case it's not set, we'll default it to 0. While we're here, the threads count getter should also be updated to count the thread IDs on the user instead of all the threads in the Vuex store related to the user. Otherwise, we'd have the same issue we had with posts count. We can do this by changing this to user. That's because this .threads is a reference to the threads getter, which is looking through the Vuex store for relevant threads, while user.threads is a reference to the thread IDs stored in the database for the user document. To account for users that don't have the thread property defined in the Firestore, we'll also default the threads count to 0. Over in the browser, we've now got 0 threads and 0 posts on pretty much all of the users. The reason for this is that our static test data set in data.json wasn't quite set up for the eventual counting of posts and threads from the Firestore as we've got it working now. I've updated the data.json in the source data below. you can copy and paste it into your data.json file. Then, delete all the collections from the Firestore via the Firestore interface. And then, we can re-import all of our data using the node Firestore import command. I'll use VS Code's built-in terminal by pressing Ctrl-Tick. And we'll give it a second to re-import. Now, when we take a look at things in the browser, we've got some counts. And adding a new post correctly increments the post count. And if we create a new thread, the count goes up there as well. So far, we've been fetching data for posts and threads from the Firestore and adding new posts and threads to the Firestore, but we haven't provided the ability yet to update those threads or posts. In this lesson, we'll make thread updates persist to the Firestore. Since we've already used the Firestore update method when appending post IDs and user IDs to forums, we can reuse that same method for making updates to the thread. In the update thread action, let's continue the same pattern of making the calls to the Firestore just before the commit. We'll need a thread ref and a post ref, as we'll be updating both the thread document and the document for its first post. The thread ref is identified by the ID passed into the action, and the post ref is identified by the ID of the first post in the thread. Next, we'll start the batch. Then, update the thread and the post to their new values. Whoops, this should be post singular ref. And then finally, commit the batch, waiting for it to finish before committing the mutations. Finally, we'll also retrieve the post and thread from the Firestore, just like we did when creating a new thread or post. We can change the definition of new thread and new post above from const to let, so that we can reassign them to the result from the Firestore. Refetching the data might seem unnecessary and is probably a slight performance hit, but it ensures that we're working with properly formatted data before committing it to the Vuex store. We also need to get the data out of the document returned with newthread.data, and then spread it into an object alongside the ID. Then we have to do the same thing for new post. This would work fine doing this here, but I'm getting pretty tired of calling .data and spreading it into an object with its ID for all the resources that we pass to the set item mutation. Let's make it so that the set item mutation can take both a document directly from the Firestore or a resource in the format that we use in the Vuex store. To accomplish this, I'll create a helper function called doc2resource. Its responsibility will be to transform a document from the Firestore to a resource that works for our data structure in the Vuex store. And to make it so that we don't have to think about whether we're working with a document from the Firestore or a local resource, I'll check to see if the provided doc has the .data method. And if it doesn't, it's a local resource that we don't have to transform. We can just return it as is. Now, over in mutations.js, we'll call doc2resource on the item before we pass it to upsert. Finally, since we're returning the thread from the update thread action, let's also call doc2resource on the return value. And we'll need to import it from the helpers file. Let's check out our progress. Awesome. Now our users have the ability to update threads. In the next couple lessons, we'll do the same for posts. We currently don't have any user interface available in our application that allows us to edit posts. Let's take a look at the mockup and see what solution it has available for us. Here, we see that a pencil icon is provided for editing posts. And if we inspect it, you'll see that it has the classes FA and FA-pencil. This means that it's an icon powered by the popular Font Awesome library. Font Awesome is a fast and easy way to add icons to any website. In this lesson, let's prepare to edit the posts by installing Font Awesome to our application. Let's go to fontawesome.com and click on Start for Free. Now, we could sign up for an account and get a link that we could provide directly to our page via a script tag. This method is fast and easy, but there's also another way that is better for performance and made especially for Vue. If we visit the Docs page and scroll down to the Using Font Awesome with little widget here in the sidebar, you'll see that there's an implementation made just for Vue. Font Awesome now has an official Vue.js component that's available for all who want to use our icons in their Vue.js projects. Let's go ahead to the API docs for the component and follow the directions on how to get it installed. We'll use npm to install the core package and the free set of solid icons. Then, we'll follow the directions for the Vue 3 installation. With all the dependencies installed, let's take a look at how to use it. The usage example here is in Vue 2, but we can alter it slightly to work for Vue 3. Let's copy this bit and paste it into our main.js file. In order to make the component registration work for Vue 3, we need to register the component on the form app instead of the Vue constructor. Back in the docs, we can see how to use an icon in the template. Let's copy the markup from the mockup for the edit icon paste it into the posts list component where icons should appear, and change out the I tag for the Font Awesome component used in the Vue Font Awesome docs. Now we've got a Font Awesome icon where our pencil icon should be. But it's the wrong icon. Let's change it out for the pencil icon. To do that, we have to specifically import the pencil icon over in the main.js file. And actually, in the latest version of Font Awesome, version 6, the free version of the pencil icon is called Pencil Alt. Then we'll use the library.add method to register it with Font Awesome. This may seem a bit tedious, but this is one of the primary benefits of installing with npm versus using the kit option that you get when you sign up for Font Awesome. This allows us to only load in the specific icons that we need for our site, as opposed to loading in every single icon and then only using the pencil. It saves both bandwidth for the user and increases performance. Let's go change out the icon where we use the component. Nice. Looks almost like it does in the mockup. Let's add just a little bit of padding to keep it from butting up right against the post text. That's better. At this point, we're up and running with Font Awesome and can continue to import any new icons we need as they come up. But I don't like how we've got code for Font Awesome mixed in with our bootstrapping code in main.js. When using a third party library that takes some involved setup, I like to extract it to its own file and keep that setup self contained. Let's do that. I'll create a directory called plugins where we can handle third party code that we plug in to our app. Inside the plugins folder, I'll create a new file called fontawesome.js. Then, I'll copy and paste the Font Awesome specific code from main.js and paste it into the new file. Now, almost everything that has to do with Font Awesome is out of the main.js file, except this leaves the line where we register the Font Awesome component with our View App instance. How do we extract that to the fontawesome.js file since it needs access to the app instance? Well, plugin is not just a fancy way to talk about third party code, but an actual code construct in Vue. Both Vue Router and Vuex are actually Vue plugins. You can see how they are registered with Vue using .use. We want to register Font Awesome in the same way. Of course, this means we will have to import it. Also, let's remove the line at the bottom of this file where we're registering the component for Font Awesome. Alright, as things are right now, this won't work because we haven't exported anything from fontawesome.js. When you call .use on a plugin, Vue expects your plugin to be either a function or an object with an install method, both of which Vue will pass the Vue app instance to. Thus, we can export a function from our plugin file, and now it will have access to the Vue app where we can register the Font Awesome component. Awesome. It works just like before, but now is isolated to its own file. One last thing I want to do for personal preference here. Let's change the name of the component from Font Awesome Icon to FA. Font Awesome Icon is just a lot to type, and Font Awesome is popular enough in the development world that FA would be enough to identify it in most cases. Besides, this reads quite nicely now. FA icon, pencil alt. Good to go. Now that we have the pencil icon in place to act as a trigger to edit a post, let's get it doing its job. In postlist.vue, we'll start by adding a click event listener to the A tag surrounding the pencil icon. We'll also call .prevent here so that we keep the browser from jumping to the anchor. And I'll just clean our A tag up a little bit. On click, we can call a method called toggle edit mode so that clicking the pencil icon once will turn editing for a post on, while clicking it for a second time should cancel editing. And it will need to know which post to have edit mode enabled for, so we'll pass it the post ID. The toggle edit mode method will set a data property, editing, to the ID that we passed in to the function. Let's add the editing property to our data and initiate it to null, as no post should start in edit mode. And now we can add a conditional to each postcard in the template. If the editing property equals the ID of the post, then show the editor for that post. otherwise show its text. Great. Clicking the pencil once toggles on edit mode, and clicking the pencil of any other post removes edit mode from the previously active post and adds it to the one clicked. However, clicking the pencil icon for the post that is actively being edited does not remove edit mode. We can fix that in the toggle edit mode method by first checking if the past ID equals the post ID that is already being edited. If it is, we set this.editing to null. If it's not, we'll set this.editing to the ID as we were doing previously. Cool. So you may have figured out that just printing the words edit mode isn't sufficient for our post editing purposes. I've checked with the stakeholders, and yeah, unfortunately, this won't cut it. Let's show the post editor component when edit mode is active. We'll also have to import it and register it. And I'll also add a call full class to the wrapper div here so that things get styled correctly. Now, when we toggle the edit mode, we're presented with a text area and a publish button. I think this is more what our stakeholders are going for. There's two things, though, that I see that need working on now. One, the text area is empty. Since we're editing an existing post, it should already contain the existing post text. Number two, the label on the button doesn't make sense for updating. Let's deal with the text area first. Since the post editor was only for creating new posts up until now, it has no way of taking in the data from an existing post and filling the form with that data. So, let's modify the post editor component to accept a post prop for editing existing posts. Posts are objects, and if the post prop isn't provided, we'll default to an object with the text property null. Next, we'll create a copy of what's provided to the post prop so that we can manipulate it locally in our component and so that we can use vModel with it. We can also remove the text property, as we'll be using post copy as the source of our data. Now we'll pass postcopy.text to the text area, replacing the text we gave to the vModel earlier. Lastly, we'll update the save method to work with postcopy instead of the text data property. Great! The post editor component should be ready now to handle existing posts. Let's pass it the existing post in post list and see if it works. For existing posts in edit mode, the text area shows the existing text. And for new posts, the text area is empty. Now let's take care of the label on the button. We could create a prop on the post editor component like button label. But since the label is really tied directly to the post prop already, a button label prop is unnecessary. What do I mean? I mean, if the post is provided and it's got an ID to prove it's an existing post, then it's a post to be updated, so it should have the label Update Post. Otherwise, it's a new post and the label should continue to be Submit Post. Using this approach keeps the interface for our post editor component as lean as possible and reduces the amount of variables you have to think about if you ever use the post editor component again. In the next lesson, we'll use this beautiful new edit mode to send updates to the Firestore and commit mutations to the state. Now that the post editor is in place and showing and hiding properly, we can focus on what needs to happen when someone clicks Update Post. In PostList.view, let's listen to the post editor save event and dispatch an update post Vuex action. We can access the event emitted from the component with Vue's special $event keyword and get the post property on it. And while we're at it, let's just go ahead and use map actions to map the update post action. Over in actions.js, we'll create the update post action. We'll destructure commit and state from the context, and the text and ID from the post. From here, we'll start assembling the updated post. It will need the text that we passed into the action. It will also need an edited at property so that we can keep track of when this post was edited and by whom. This data structure was already mapped out in the data.json file and looks something like this. The post is now ready to save to the Firestore. Now, just like we've done with updating the thread, we'll fetch the post afresh from the Firestore and set it to the state by committing the set item mutation. Now, when we change a post and click Update Post, the text area goes blank. But if we toggle edit mode off, we'll see the changes reflected in the post text. And when we refresh the page, the updates are still there. Great. Let's make it so that clicking Update Post hides the post editor and shows the newly updated post. To make things read a little better, we'll extract it into a handle update method. Let's also provide an indicator in the user interface that the post has been edited. Very nice. Lastly, it's kind of weird that we show the pencil icon on posts that aren't our own. Let's only show it for our own posts. That's better. Up until now, we've briefly talked about the power of On Snapshot to provide live updates to the application, but we haven't really demoed it in action. Right now, this post says, I hate all filthy pets, but I love my hounds. We can look up this post in the Firebase console and make a change to its text. And then, on the thread page, the post automatically updates with the new content. We can do the same thing by editing Batman's post below in a new browser window, and you'll see that it updates live in the original browser window. This isn't just a feature between the windows on my machine, but a powerful feature of the Firestore that works across the entire internet, no matter where the different users are. There is an issue thus far, however, that's a consequence of the on snapshot method and its ability to provide these live updates. Because we dispatch fetch item or fetch items, which calls fetch item, in the created hook of each page, we're registering an on snapshot listener every time we visit that page. Just like any other event listener in JavaScript, the on snapshot listener should be cleaned up to prevent memory leaks and performance issues. Let's use a console.log to get a better look at the issue. We'll add a console log in the on snapshot callback in the fetch item action. Back on the thread page, we'll refresh the page and then clear out the console to prepare to see the snapshot console log when we make an edit from the Firebase console. Back on the thread page, we see the post updated as we expect. But we also see our console log. Notice here that it only fired once. That's good, and exactly what we want. But remember, we're dealing with a single page application. If we navigate away from the thread page and then come back, we've actually unintentionally got two active event listeners on the exact same thread, posts, and users. To see that, let's make another update from the Firebase console. Now, you see the snapshot console log appears twice, even though we only made one update. Notice the 2 here next to the console log. Even when we navigate to a different page that has nothing to do with that particular post, if we make another change, we'll see the console log again. So, as is, the application not only registers multiple snapshot listeners for the same data, but will continue to listen to resources from previously visited pages, even when those resources are no longer relevant. As you might imagine, this issue will only compound the more pages we navigate to on this site. So, how do we fix this? How do we unsubscribe from the onSnapshot event? Conveniently, the onSnapshot method returns an unsubscribe function. All we need to do to unsubscribe from listening to the snapshot now is call unsubscribe. But when do we call it? One option would be to call it in the callback for the snapshot. This is quick to implement and it solves the issue, but it kills the live changes feature as the listener is killed as soon as it's set up. Because the issue comes from calling the onSnapshot function in the created hook on each page. What we really want to do is call unsubscribe anytime the page changes. In order to do that, we can create an array to hold all the unsubscribe functions, push the unsubscribe functions into it as they become available, and then, when the user navigates to another page, go into this array and turn off all the listeners by calling each unsubscribe function. Let's start by bundling up all the unsubscribe functions that get created in the fetch items action into an array so that we can loop through them and call them all at once. We'll create this array in the Vuex stores state. Next, we'll need to create a couple mutations to alter the unsubscribed state. One, to add new unsubscribe functions to the unsubscribes array each time we call onSnapshot in fetch item. And another mutation to clear out all the unsubscribe functions once they've been called. With the mutations available, now we can commit the append unsubscribe mutation in the fetch items action to add new unsubscribe functions to the array as they're created. Let's also create an action to call all the unsubscribed functions in the unsubscribes array. We can call it something like unsubscribe all snapshots. In this action, we need to loop over each unsubscribed function in the array and then call it. After all the unsubscribed functions have been called, we can commit the clear all unsubscribes mutation to discard all the unsubscribed functions we've just called. This action is exactly what we need to clean up all the on snapshot listeners. But when do we dispatch it? We could go through every page and dispatch it in the unmounted lifecycle hook so that it runs when the page component is unmounted or destroyed. However, in every new page that fetches data, we'd have to remember to dispatch it. Also, it behaves the same for every page and has no foreseeable customizations needed on a per page basis. So, the better option would be to call it in one place that runs on every page. For this, we can use the global route navigation guard before each. We've already seen the before enter navigation guard used specifically on the thread show page. The before each navigation guard is much the same, except that it runs before page changes on all the routes. Over in router/index.js, we can register the global before each route guard by storing the exported router instance to a variable before exporting it. And then defining a before each method on the router with a callback function. In upcoming lessons, we'll learn how returning different values from this callback function can affect the navigation in different ways, such as redirecting it or canceling it altogether. For now, we won't return anything, but instead just dispatch the unsubscribe all snapshots action. Finally, to have access to the store here, we'll need to import it. Now, let's run the same test with the console log we did before. Whoops, I forgot to remove the unsubscribe that kills it immediately. Now the console log only appears once because we only have one active event listener. Perfect. Also, we can navigate to another page that doesn't have the post on it, and we will not see the console log at all. Awesome. Let's clean up that console log. Stranded event listeners are a common source of memory leaks and performance issues. It's very important to remember to clean them up, as we've done here.